Hi, so lately we've been looking at these things, mushrooms and fungi, and what we could actually do with them because they're truly an amazing creature. I say creature because they're more closely related to animals than they are plants, but of course they're owned far more by themselves. But they have astonishing properties. One of them, we've been looking at the mycelium and how they've been used to make a glue to hold together structures of an amazing diversity. And of course somebody mentioned, what about using them for energy storage? Well, of course you can use them for energy storage. I mean, what can't you use these things for is becoming the question, isn't it? So I thought I would do something on energy storage and using mushrooms to create an energy storage device. Because what we're going to create is a supercapacitor, and the routine for this is pretty much always the same. You find whatever material it is you want, this time it's the mushroom, and carbonize it, because we need a carbon structure. The carbonization process is always the same routine, it's not that different. We're going to carbonize these at 700 degrees centigrade for an hour. That should turn them into a carbon. Then we're going to activate them, then we're going to make a supercapacitor out of them. Now, in order to carbonize these without burning them away, what we need to do is put them in a protective environment. Now, normally you find the protective environment to be argon gas. That's a bit difficult to arrange in a small home lab, so all I do with them is find a container, something will cope with 700-800 degrees centigrade. This will actually go up to 1000 degrees centigrade. Steel works just as well. Drop your material in your container, and what I've got here is an awful load of activated carbon, and all you do is cover them with activated carbon. There we go. We have created our protective environment. Now we need to put it into a kiln. This is the homemade kiln I made about 2 years ago, something like that. I put that mushrooms in there, turned it on to 700 degrees centigrade and just let it ramp itself up. It ramps quite quickly, sort of a degree or two a minute, something like that. Get it up to 700 degrees centigrade and then leave it for an hour. So once that's had an hour and time to cool down, we can pick it out and sift out our mushrooms. One thing that's really cool about this method actually is whatever organic material you put in there retains its shape. So the mushrooms are still there in mushroom shape. They've just shrunk a bit because they've lost the water, and there's a mushroom. So out of 250 grams of the raw mushrooms, we get 5 grams of carbonized mushrooms because mostly they're water. Now we want to take our carbonized mushrooms and grind them up into a very fine powder, and of course we can do that in a kitchen blender. We've got 250 grams of mushroom, we've got 5 grams of mushroom carbon, so the yield isn't great. Now we could activate this using potassium hydroxide, so you do something like a 4:1 weight ratio. So we've got 5 grams here over the carbon, and we'd add 20 grams of potassium hydroxide, heated at 700 degrees centigrade for an hour, and it would activate it. However, we'd only get about 20% yield. So we'd get 250 grams of that, 5 grams of that, and 1 gram of the activated carbon, which is not a huge amount when you think about it. But I'm going to make this into a supercapacitor paste anyway without the activation process. We'll see what we get. Now, in order to make it into a supercapacitor paste, all I really need to do is make it liquid and add a binder. And the binder I'm going to use is an acrylic binder. It's just an art binder. Usually, you add about 10% of the binder. So I'm going to add somewhere between 10 and 20% of this by weight. So half a gram, 1 gram of binder, and then make it up into a paste with some DI water. And that is our supercapacitor material. There we go. We've got our pretty paste. Now all I've got to do is put it onto something. I'm going to use a bit of graphite foil, slice off a section, paint some of this on, let it dry, and we will have our supercapacitor. So once it's dry, cut it in half so you've got 2 pieces. Then get a bit of kitchen towel, pop that in between, bit of electrolyte, pop that on top. Says here, if you don't drop it, there we go. Pop that on top like that, and that is a working supercapacitor. So let's give it a bit of charge and see if we can get something out of it. So there's my capacitor, a lump of wood and a little metal weight just to give it a bit of weight to keep everything in contact, and I'm going to charge it at 1.6 volts. So there we go, charging away. That's actually pretty awesome. Okay, if I disconnect that and connect a battery up to this little motor, we should see that motor spin. Okay, I don't intend doing much in the way of proof of this because it was taken directly from a research paper. And what they reckon is it's 150 farads per gram, somewhere around about there, charge voltage 1.6 volts. But a demonstration of how you can take mushrooms and turn them into power, which I thought was just awesome. And it's following along that theme of what we can do with mushrooms, and it seems, if we think about it, we can change the world. Anyway, mushrooms to power. That's a lot of power for a little thing like that. Whoa. That is whoa. It's completely disconnected from the power supply. It's running off this battery.
Whoa! He's just going and going and going.
I'll give a link to the paper.